Electrolytes are defined as compounds that form ions when dissolved in water. The resulting solutions conducts electricity. So when we dissolve these solutions, we have ions that are going to be forming in those solutions that are going to facilitate the flow of electrons. Consequently, non-electrolytes are defined as a substance that does not form ions in solution. And we're not going to see electricity, or we're not going to gain electricity from these non-electrolytes. So let's kind of look at what we can, with a couple examples of this type of problem. So if we have sodium chloride, which is one of our textbook examples of an ionic compound, and we dissolve it in water, it's going to break down into sodium plus cations plus chloride minus anions. In this particular case, NaCl is the solute, and the water is going to be the solvent. So since we produce ions in solution, our NaCl, or Na plus Cl minus, is going to be our resulting solution. And at the molecular level, this is going to be a homogeneous mixture. So when we look at these mixtures, we can look at the properties that result from these. If I have a solution that contains sodium plus cations and chloride minus anions, it's going to conduct electricity. So as we can investigate some of these electrolyte solutions, we can look at the various properties. And chemists classify these electrolyte solutions as strong electrolytes and weak electrolytes. So we can kind of look at what types of compounds we will see, and we can observe based on their properties. So if we have an ionic compound, we typically observe these to be strong electrolytes. And we can predict, based on the formula and the composition of these compounds, where if we have an ionic compound, it's a metal bound to a nonmetal. Molecular compounds, on the other hand, are non-electrolytes. And typically, we can look at these molecular compounds by looking at a nonmetal bound to another nonmetal. The exceptions are acids and bases. And these are molecular compounds, but we observe different behavior. If we have a strong acid, it's going to be a strong electrolyte. If we have a strong base, if we have a strong base, it's also going to be a strong electrolyte. If, on the other hand, we have a weak acid or a weak base, we're going to have a weak electrolyte. And the strength of the electrolyte solution is going to be based upon how much, electricity we can observe. A common experiment to illustrate this effect is if we take a light bulb and try to light up that light bulb from that solution. If we have a strong electrolyte, the light bulb is going to be very, very bright, where if we have a weak electrolyte, it's going to be much, much more dim. So we can look at a couple examples of our strong and weak electrolytes. For example, if I took nickel nitrate or nickel 2 nitrate, which is NiNO3 twice, and we dissolve this in water, the resulting solution is going to have nickel 2 plus cations plus 2 NO3 minus anions. It's an ionic compound. We have a cation and an anion, and this is going to be a strong electrolyte. If we took C12, H22O11 as a solid, and we put it in water, we're going to get C12, H22O11 in aqueous solution, and it's not going to break down into ions. So this would be a non-electrolyte. If we took HCl as a gas and we dissolve that in water, we're going to get H plus ions plus Cl minus ions, and we're going to observe a strong electrolyte. Now, HCl is a molecular compound, but it's one of those examples of an exception which is a strong acid. In the next couple sections, we're going to talk about behavior of acids and bases, and we're going to be able to identify whether they're strong or weak. That's going to come into play with a lot of these properties. If, on the other hand, we have acetic acid, which is HC2H3O2, if we put this in aqueous solution, it's going to break down into H plus C2H3O2 minus. This is going to be a weak acid, so instead of putting this arrow here, we typically write an equilibrium expression up, indicating that this is a weak acid, which will give us a weak electrolyte. So if you're asked to identify a particular electrolyte solution and characterize whether it's going to be strong, weak, or a non-electrolyte, you have to look at the composition, see what happens when you dissolve it into water, and you can determine and classify each of these as strong or weak electrolyte based on the composition of the compound that we're analyzing.